Hey guys, good morning. It's hard to believe, but for the seniors, the time is growing short. And I gave a lot of thought as to a way that I might allow you guys to have a little bit more contact to one another, with one another, and fellowship with one another in the time that we have remaining. So I thought, well, let's set aside bacon mugs and my YouTube nonsense for a little bit and give those introductions to you. So here's what I would like to propose. And I'm going to give you some details over here in a minute, but for today's intro, I want to describe how for the next week, I'm opening those intros up to the seniors. So I'm giving you guys the opportunity to take over that spot. Now be aware that even though you have 2 days technically where you don't have school next week, we're still going to allow you to go ahead. I'm going to go ahead and allow you to produce intros for those days if you see fit. So today is Thursday. So that means between tomorrow, Friday, and next week, we have 6 possible spots for these. So let me explain some details of what I'm envisioning. Past this point, your creativity reigns. Number 1, seniors only. Okay, this is open only to seniors. We can look at the possibility for the rest of it later, but this is open only to seniors. Number 2, 2 minutes maximum. Okay, obviously, we try to keep these things short so that they don't overtake the video. It may contain 1 or more participants, as long as you're maintaining proper distance from one another. I know some of you might necessarily come up with an idea that allows you to cut back and forth. However, all of those participants need to be seniors. Remember that any characters, themes, or tone of the piece, even though we know there are obviously some differences in the way that you're learning at home, need to be school appropriate and fit both the charism and the rules laid out in the school handbook. All of those videos will be viewed, reflected on, and chosen by me. However, be aware that I do reserve the right to share those videos with anyone else on the faculty. That does also mean the administration. It does mean that thinking through what your video might be about, what your intro might be about before you share it is probably a good idea. Now, you can begin as early as tomorrow, which is Friday, April 24th. Now that does mean that if you have an idea that you want to do, it needs to get to me quick. You need to really think of it as the day before. As long as I get the video the morning before, that gives me enough time to view what we have and make a selection. But if you have an idea for tomorrow, you've got to get it to me before tonight so that I can edit it in to everything else that's going on. So remember, that's going to give us 6 total days of possibility. That's tomorrow, April 24th, and then the following days next week. Now remember that even though Wednesday and Friday seniors, you don't have class, Wednesday I will just put the intro part of the video up for your enjoyment, and Friday my other students have class, so there will still be an intro there as well. You'll also get the usual weekly overview from me on a Monday to let you know what it is that you're going to be doing. So, seniors, this is your chance to get a little creative and make something for the rest of your classmates to enjoy. Be aware, juniors and freshmen will also be seeing these videos as well. I want to wish you the best of luck. It can have anything to do with the theme that I've established, or it could be completely new, as long as it meets the rules that we've already discussed. Have a great day, and I will see you tomorrow. Hopefully, along with a bunch of other people as well. Have a great day.
Okay, good morning guys. So just to reinforce again before we get to the actual math, what I talked about in the opening of today's video. Seniors, I want to encourage you. Come up with an idea, short, little, big, it doesn't matter. Be sure to share it with me through your Google Drive so that I'm able to access it and get a look. And you might find that starting tomorrow, your creativity is cut into the beginning of our class videos. Give you that chance to kind of have that last contact with everyone as we wind towards the end of the school year. So speaking of which, I want to make sure we cover before you leave the basic rules of how we work with these logs. So we've talked about all the different properties, product, quotient, power, cancellation, etc. We're going to talk about 2 more. So this first board is going to show us how these 2 properties work. Then you're going to see a dissolve, and we're going to talk about how we use them to solve 2 different kinds of problems. So the first one is the property of log equality. It is very, very simple to understand. It basically means that if you have the log base b of u, and you know it's equal to the log base b of v, then you know u is equal to v. And if you just look at what's written here, okay, two things that are logs with the same base that produce the same answer, that means that they have to be equal to each other. Well, it's really pretty simple. We're going to use that to solve equations. So if you take a look here, this is not really too difficult to understand. If we have 2 times the natural log of x equals the natural log of 16, and they say, okay, solve for x. Well, we've got to get rid of these natural log denotations. We can't work with them in an equation, not really. And don't be fooled, you also can't really divide by them. So those of you that are thinking, well, can I work with these like sine, cosine, etc.? Not really. So don't fool yourself. We know we're not ready until we basically have the logs or the natural logs by themselves. In other words, this 2 coefficient in front means we're not ready to do our next step. We're not ready to use this property of equality. But it's not hard to see what to do. Power rule means that since this is in front, we can make it an exponent for the 2. So we get the natural log of x squared equals the natural log of 16. So now we have 2 things with the same base. Remember, the base of natural log is e. So these are both log base e of x squared equals log base e of 16. That means we can set these 2 things equal to each other. Pretty simple. So we get rid of the logs altogether, the natural logs, and we're left with x squared equals 16. Take the square root of the whole thing. And we're given 2 possible answers, x equals positive 4 or negative 4. And this is nothing new. We've done this 100 times. But be aware that logs, the argument of a log always assumes a positive value, a positive x value. So if you've looked at those graphs of logs, if you've done on the quiz and on the homework, you'll see that they're always on the positive x side. So the same thing here. That means that negative 4 can't be one of our possible answers, so our only possible answer here is positive 4. That's a basic sense of how that works. Sometimes we need to change the base. Let's say we're adding something that's log base 6 to something that's log base 9. Well, those aren't like terms. We can't work with them. So we have to find a way to come up with a change of base to allow us to work with them and use our other rules. So that's our change of base property. And here's the basic idea. If I have something u that I'm taking the log of with base b, and I want to change the base to anything else, it doesn't matter what it is, we're going to call that base a. And when you see it here in a minute, you'll see how it works. Then the basic conversion is this. We're going to set up a ratio. That's log, whatever our new base is, log base a of u, in other words, what we started with, over log base a of b, which is our original base. So the short version is this. Both the numerator and the denominator have a new base for the log. I'm using my original value in the numerator, and I'm using my original base in the denominator. So to put this plainly, and you'll see why this might work this way. See, it allows us to simplify and eliminate logs if we could just compute what they are. So let's say we had log base 3 of 10. And you thought to yourself, well, what power can I raise 3 to equal 10? And you know that's going to be some weird value. Well, could we change that to a base that would allow us to at least eliminate part of it? So if we change that to log of base 9, and you'll see why we do that here in a second. Does it have to be 9? No, it could be anything, really. Then log base 9 of 10, there's my original value, equals log base 9 of 3, the original base. So I just want you to see this goes here, this goes there, and then our new base is whatever we want. And even though this doesn't necessarily get us too much closer, I hope everybody gets that we could calculate the value of log base 9 of 3. Okay, we could kind of think about what that might be. So let's look at how we put it into practice. How do you actually work with this in your calculator? So here's the shortcut. So remember that your calculator can really only work confidently with 2 bases with logs. That's log base 10, that's our common log, and that's log base e, that's our natural log. So really, anytime you get one of these change of base problems, unless you have to change the base to something else that's already in the problem, you're going to be thinking about log base 10 or log base e, because you can punch those into your calculator. So let's say it said, okay, use change of base in your calculator to calculate the value of log base 9 of 200. In other words, 9 raised to what power gives us 200? Well, calculator doesn't like base 9. So we're going to change it to base 10. So remember, even though we don't see a base here, it's the common log, so we can assume it. So log base 10 of 200 over log base 10 of 9. Remember, if the 10s aren't there, we assume it's that common log. By the way, this could also be natural log of 200 over natural log of 9. Either way is going to produce the same value. And if you're not sure, put it in your calculator so you can see. This I can put into my calculator. Log of 200 over log of 9 gives us approximately 2.4114. So that means that 9 raised to the approximate 2.4114 power gives us 200. So equality, last property, change, well, next to last property, change of base, last property. And now we're going to look at two examples after the dissolve of how we use those. So I will see you on the other side of the dissolve. Okay, so in general, here's what you're going to be asked to do when you're working with logs from a purely theoretical perspective. You're either going to be asked to treat them as equations and solve for x. We're going to look at one like that here. Or you're going to be asked to change the bases so that everything can be combined into a single log. You're going to look at that here. And it just means we're going to pick what we need off of our menu to get where we need to go. Now, the first thing I'm going to tell you is anytime you are trying to change a base, you are generally going to be better off changing the larger base to equal the smaller one. So let me show you what I mean. If you look at this right now when they said solve for x, we've got 2 times log base 3 of x equals log base 9 of 16. Well, I know eventually I'm going to have to get these bases to match using my change of base. But do I turn the 3 into the 9? Or do I turn the 9 into the 3? Right? And you might think that the choice is fine either way, and technically it would be. But I will tell you that in most cases, these problems are going to be set up so that changing the larger base to equal the smaller one is generally going to be the way to go. So let's imagine that we did that. So we're going to leave this side alone for now. We'll come back to it in a minute. So we're going to change this log base 9 of 16 to log base 3. Remember, we can choose that arbitrarily. We're choosing 3 here because it matches. And if we can get them equal, then we can set x equal to something and we can solve for it. So remember, what's our rule? We've got log base 3 of our original value, that's 16, over log base 3 of 9, our original base. Now, if you think about this for a second, we can work with one of these two. We can't really calculate log base 3 of 16, but we know log base 3 of 9. That's just 2, 3 raised to the 2 power. Okay? And I'm going to go ahead and write it out this way so you can understand it. I'm going to skip a step. But we would have log base 3 of 16 over 2. So I'm just going to make that 1/2 here on the front because that'll make more sense here in a minute. So that's 1/2 log base 3 of 16. Right? Still left with the same thing on the other side. But now you may be thinking to yourself, okay, let's look at what we can do here. I've got this coefficient at the front. I know I can make that a power. So I get log base 3 of x squared. And you should see, okay, now we're getting pretty close. We've got 2 log base 3's. We've just got to deal with this right here at the front. Now, because I don't have a lot of room down here, let me see if I can just show you with a napkin what's going on. Remember, when we have a coefficient at the front, we can use our power rule to turn that into an exponent here. And remember, what does it mean for something to be to the 1/2 power? It really just means the square root. So the square root of 16 is 4. And now if you look, I've got 2 equal bases, so I can set the 2 logs equal to one another without the log signs in front. So I get x squared equals 4. I take the square root of the whole thing. That gives me x equals positive or negative 2. But remember, the argument of a log is that the value is always positive. So my only possible answer here is positive 2. So again, using our rules, changing bases, using power, etc., to get to this point where we have 2 things that are equal and then set them equal to each other. How about this one? We're not solving for x here. Hopefully you'll see, oh, well, there's an x and a y, so there's not much we could solve for here anyway. Instead, they're saying, make this into a single log. So you'll notice we have log base 4 of x plus 3 log base 2 of y. We've got to get the bases equal to one another first. Remember, change the larger base into the smaller base. So let's do our change here. This is going to be equal to log base 2 of x over log base 2 of 4 plus 3 log base 2 of y. Hey, you should be thinking to yourself right now, I can do log base 2 of 4, right? 2 raised to what power is 4? Okay, well this is just going to become 2. And I tell you what, I'm going to go ahead and deal with this part over here too. We're going to move this coefficient to the power position, so we get log base 2 of y to the third. Hopefully you can see now we're chasing this thing down. Everybody here should now be able to see, just like we did in this last problem, something over 2 means we can write this as 1/2 log base 2 of x. And now using power rule, we can move that to the front. We can move that to the exponent position. And now we've got something we can work with. Now we're really close. Can everybody see? We've got a log base 2 of this, a log base 2 of this. There's no equal sign, so don't fool yourself that we're going to set those two things equal to each other. Think for a second, if you remember yesterday's work and the work from Monday, what is the rule that we can use to help us make this into one log? Be aware that we're adding two things together, which are logs of the same base. I'll give you 5 seconds. If you thought the product rule, you'd be right. A log base 2 of this plus a log base 2 of this just equals a single log of this times this. So our final answer here is going to be, and we're going to put all this in parentheses, log base 2 of x to the 1/2 times y to the third. You could also write this as square root of x times y to the third, and that answer would be correct as well. So we're going to practice with this a little bit. Really try to hit the ground running because we've only got a couple of days left with seniors, so I want to hit a sweet spot. Don't forget, if you come up with an idea, big, small, no greater than 2 minutes, go back at the beginning of the video and take a look at the rules. Send me something today. I would love to add your creativity to the work we all see. Have a great day, and I will see you tomorrow.